So, good evening, friends. The objective of today's session is to get familiarity with the software and why we are using a SmartPLS rather than covariance-based SAM. And we will do one more exercise on a SmartPLS. The objective is to get familiarity with the software. So, yesterday we have discussed some of the concept, just a small revision. In SmartPLS, we will make diagram using the yellow rectangles, which are representing the statements, and the blue circles, which is representing the construct. Construct is latent. It is also known as factor, latent variable, construct, and so there are many names of this. And normally, when you see the questionnaire, these are the statements, or they are also known as items, and this is the construct. So when you make a model, the yellow rectangles represents the items and the blue circles are representing the construct, and construct is measured by these items. We don't have any data for these blue circles, so their value is coming from the blue rectangles. So this model is of two types. One is inner model between the blue, and the second part of the model is outer model, which is between the blue and the yellow. So blue and the yellow is outer model, like blue and yellow. So this portion is called outer model, and blue, between blue and blue, it is known as inner model. So there are two types of constructs we will use. One is formative and second is reflective. In formative, the direction of the arrow is from yellow to blue, like this. In reflective, the direction of the arrow is from blue to yellow. So we assume that in formative construct, the construct is the outcome of the items, and in reflective, we assume that the items are the outcome or the reflections of the construct. So we have two types of models. So this is the reflective, this is the formative, and there are different ways and means to treat the formative and reflective. So slowly and slowly we will discuss that. Okay. So from where we get the knowledge that which of the construct is formative and which of the construct is reflective, the basic reason is theory. Theory will tell you whether the construct is formative or reflective. And sometimes the nature of the relationship is also telling you. Correlation is one of the important statistics which is telling you whether the construct is formative or reflective. The formative construct have very low correlation between the items, and the reflective construct have very high level of correlation between the items. So this is the difference between formative and reflective in terms of correlation between the items. PLS is also giving you one method, a statistical technique, that is known as confirmatory tetrad analysis. So we will do in detail how CTA will tell you whether the construct is formative and reflective. Then we discuss the zero order, first order, second order, and this topic we discuss in much detail. So just one line definition. So any construct which is represented by its item is called zero order. Any model where there are more than two zero order constructs, two or more than two, that model is called first order model. And in any diagram, if one construct consists of different constructs, so this is the construct, it is measured with the items of these constructs or indirectly from these constructs. So this is called second order construct. Now from today, we are discussing this. So there are some important concept which you should understand. Like, what is the meaning of endogenous? What is the meaning of exogenous? So in layman, endo means dependent and exogenous means independent. But if you go in much detail, it is found that whenever you run the regression model, the error term is should not correlated with the x independent variable. This error term should not be correlated with the independent variable. This property is known as exogeneity, exogenous. However, it is found that the error term is correlated with the dependent variable. This property is known as endogeneity. So why a variable which is having correlation with the error term is called endogenous, and the variable which is not correlated with the error term is called exogenous. So the correlation with the error term is the basic root of defining whether the variable is exogenous or endogenous. Now, from this concept, there is a problem which is emerging slowly and slowly. So, what is the problem? That how much y can be explained by x and how much y cannot be explained by x. Like, for example, normally in a business, the promoter of every business want to increase the revenue, decrease the cost, increase the market share, increase the sales. So this is the objective. So all these objectives are the dependent variable, and dependent variable is defined by, because to increase the sales, you have to increase the advertisement or have to increase the quality, have to increase the R&D. So these are the independent variables which are increasing the sales. R square, one of the parameter is R square. R square will tell you that how much y can be explained by this. But if I ask you, is it possible that we define 100% y by the x, by the independent variable? Answer is no. The theory say that at least 50% of y should be explained by the independent variables. At least how much? 50%. So rest of the amount is unexplained, and then unexplained is goes into the error term. So lesser is the explanation of y, more is the correlation of the y with the error term. This problem is known as endogeneity. So when you send a paper of PLS, the author, the reviewer may ask you one query that because the SmartPLS is not giving you any of the goodness of it based on the error term, how you manage the endogeneity problem in the SmartPLS model? This is the common question you will get from the reviewer when you send a paper based on SmartPLS. I have seen many this type of questions. So you must be ready for that. The explanation of this is in terms of R square, in terms of effect size, in terms of Q square. So there are many parameters which we can calculate from SmartPLS but cannot be calculated in other software like MR. So we have to we should be ready with this answer. Even when you are giving a viva of the PhD or you are giving a presentation, so whenever a problem of endogeneity will come, so you must know, you must understand that what is the endogeneity. So simply in simple language, I am telling once again that the proportion of y which cannot be explained by the model and explained by the error term, and because of the high correlation with the error term, the model is not fit. This problem is known as endogeneity problem. Okay. So in panel data, the endogeneity problem is of another nature. So what is endogenous variable? Endogenous variable is simply dependent variable and may have some correlation with the error term. X is exogenous variable, and in SAM also we have some mediating and moderating also. So we also discuss on mediating and moderating someday. So if you see this model, all the like degree of internet savviness, it is a independent, so it is called exogenous. Performance expectancy is also exogenous. Convenience exogenous. This is exogenous habit. Facilitating condition is exogenous, and they are causing the behavioral intention. Behavioral intention is dependent on these. So in this, if in this sense, we can say the behavioral intention is endogenous, but behavioral intention is not the complete action. It is just an intention to adopt. So now we want to see how the intention will cause the adoption behavior, actual usage behavior. So usage behavior, actually usage behavior is final dependent variable, and final dependent variable is called endogenous construct. The final usage behavior is depends upon the intention. So intention comes in between actually. So any construct which comes in between the two, like it is coming in between the exogenous and the usage behavior, so it is called mediating. And some construct may be acting as a moderating. So moderating construct, any of the independent construct can also be a moderating construct. So that we will discuss. I hope in this diagram you can easily identify which is exogenous, which is mediating, and which is endogenous. And like in this diagram, in this model, we have retention strategies is a second order construct, and retention strategies is a second order. Why? Because it is measured by all the in zero order construct. 1, 2, 3, 4, 5, 6, 7. So there are 7 zero order constructs which are measuring the retention strategies. So retention strategies don't have its own item. It is measured by all the 7 constructs. Then retention strategies influence the turnover intention. Turnover intention reduces the employee turnover, and turnover will causes the organization performance. Right. So in this model, turnover intention and employee turnover, they are mediating. They are mediating construct because they are coming between retention strategies and organization performance. So, retention strategy is a second order exogenous construct. Organization performance is a endogenous construct. So one of the objective of the SmartPLS is to examine the complicated relationship between the different constructs. And the objective of mediating construct is to explain the relationship in much detail. So we have to develop all the framework and can examine with the help of SmartPLS. And we are also having the MO software In MO software, you can see we can make all these type of diagrams. Like this is a CFA diagram. The first diagram, if you check, this is a CFA diagram. This diagram is used to examine the validity of the construct. This is a SAM diagram. This is a second order construct. So there is a difference between PLS diagram and the MOS diagrams. If you check, we are using the error terms. So there are so many error terms which we are using in MOS. All the error terms are not available in PLS. So these error terms are not available in PLS. You can see. So all the red I'm doing red marking. These are all error terms, and we are not using error terms. Even we cannot use this model in PLS. In PLS, with the same diagram, you can run CFA and SAM. So you have to remember that in MOS, you have to make separate diagram for validity and separate diagram for SAM. But in SmartPLS, we can use the same diagram for both, for validity as well as for hypothesis testing. So both actions we can do in the same diagram. The another thing is that like these are PLS based diagram, and you can check we are not using the error term. And but the difference is that if you go to MOS, all the constructs are reflective in nature. So you can see that the arrow always emerges from the construct and goes to the item. The direction of the arrow come from the construct and join the arrow items. So this is one of the mandatory requirement of MOS, that you can use only reflective construct. You cannot use any formative construct. But in PLS, if you check, this is a formative construct. Why? Because the arrow direction of the arrow is from item to the construct. So like this is also a formative construct. This is also a formative construct. This is also a formative construct. So whenever this is also a formative construct, right? So whenever we are using formative construct, you have no other option other than SmartPLS. So this is one of the benefit of SmartPLS, is that if you are using formative construct, the SmartPLS is very effective in handling that. Another reason is that if you check this, this is a single item construct. Construct is having only one item. It is having only one item. So this is not possible in MOS. In MOS, there is a rule of 3. Minimum number of item in MOS is 3. If you have less than 3 items in a construct, MOS will give you a problem called identification problem. But in SmartPLS, we don't have identification problem. So even if you are having the single item, you can use SmartPLS. SmartPLS is very effective in that also. The another reason I'm telling you, MOS is not handling the categorical variables. Like for example, if you have age group, gender, marital status, so these variables cannot be used in MOS diagrams. But in SmartPLS diagrams, we can also use these category variables. So these are the differentiations between MOS and PLS. Why we are using MOS and why we are using PLS. So 3 major important differences I told you. One, reflective and formative. Formative is allowed in SmartPLS, not in MOS. Then single item is allowed in PLS, not in MOS. Category variables allowed in PLS, not in MOS. So these are the 3 important reasons of differentiating between the two. Okay. Now, one more thing. The model in SmartPLS is divided into two parts. So we call it inner model and outer model. What is inner model and what is outer model? See carefully, because software will ask you that what values you want in inner model, what values you want in outer model. So between blue and blue, between construct and construct, this is between construct and construct. So between construct and construct is called inner model. And between this green dotted, if you see dotted green lines, this is between construct and item. So the relationship between the construct and the item is representing you the outer model. So when I ask, if software asks you what is inner model means the model representing the relationship between the construct. And the outer model is representing the relationship between the construct and the item. Okay. So if you see this diagram carefully, so the number, these number 1, 2, 3, and 4, these numbers are representing the relationship between the blue and blue. Like for example, what is the relationship between interpersonal relationship and perceived work quality? So it is represented by these numbers. So there are different values you can put here, like you can put path coefficient here, you can put the t values here, you can put the p values here. So the values which you are seeing are basically the t statistics. Path coefficient always comes between 0 and 1. So anything which is coming between the blue and blue is representing the relationship between the construct. And if you see the outer model, the relationship between blue and yellow. So the relationship between blue and yellow is represented by the outer loadings. So this is called outer loadings and weights. Now just listen this sentence very carefully. If your construct is reflective, these numbers are known as outer loadings. If the construct is formative, these numbers are known as outer weight. So once more, uh, if the construct is reflective, these numbers are known as outer weight, outer loading, and for formative we call weight. So reflective loadings and formative weights, and these numbers are representing the correlation between the items and the construct, and they also comes in between 0 and 1. For a reflective construct, these numbers should be more than 0.7, and for a formative construct, many of these numbers should be less than 0.7. So for a reflective construct, these numbers are required to be greater than 0.7, and for a formative construct, so most of the numbers are less than 0.7. So this is the way we interpret the numbers. So I hope now you have clarity between outer model. Outer model means the model which is showing you the relationship between the construct and the item. Outer, and inner means the relationship between the constructs. Okay. So in this case, you can imagine very easily that which portion is inner model, like this portion is inner model, and these are outer model. And if you see carefully, for example, CRM is a reflective construct. So all these numbers should be greater than 0.7. And if any number is less than 0.5, you have to drop it. So all these numbers are known as outer loadings. Outer loadings should be greater than 0.7. It is the mandatory requirement of the construct. And this is the formative construct. Digital marketing practices is actually the formative construct. You can see carefully. And whenever we are using the formative construct, the outer weight, these numbers are known as outer weight. So outer weight should be less than 0.7. So most of the numbers you can see, they are less than 0.7. Okay. Now the basic question yesterday also many uh, people ask me that what is the difference between CBSM and PLSM? So these are the basic questions, that what is the difference between CBSM and PLSM, when to apply CBSM and when to apply PLSM, and which method is better. So some of the answers I'm giving to you, like if you want to see the difference, the yellow blue is PLS based SEM, and all these diagrams are representing the covariance based SEM. So there are two types of structural equation modeling. There are two families of structural equation modeling. One is covariance based SEM, and the another is the partial least square based SEM. In simple language, the partial least square based SEM is the application of the regression model, and covariance based SEM is based on entirely matrix algebra. So it is based on variance and covariance matrix of the variables. And they are applying maximum likelihood estimation method for calculating all the numbers. So the mathematics is different, the model is different, the way of calculating all the parameters are different. So everything is different. So covariance based SEM is a totally different mathematics, and PLS based SEM is totally different mathematics. And where to use when? This is the questions which everyone is asking. So when to use CBSM and when to use PLSM. So these are some of the reasons now we are going to discuss. So if we talk about CBSM, the softwares are Lizerl, MOS, EQS, MPLS, R, Stata. In previous days, before MOS, Lizerl was very popular, but now MOS is very popular. So whenever you say CBSM, it means MOS. Otherwise, we are having the facility in Stata or MPLS, but they are not very popular. The most popular software is MOS. Similarly, in PLS, the SmartPLS is the name of PLS STEM. So I have seen the PLS graph is another software, but nobody is using that. So SmartPLS and the distribution assumptions. If you say the CBSM required normal distribution and multivariate normality, all the variables taken together should be multivariate normal. However, PLS-SAM is not assuming the normality assumption. It is a assumption free, and because of this, the research scholars are also saying this non-parametric SAM. So we don't have any normality assumption in PLS. It is one of the benefits that even if you have small data set, even if you have non-normal data set, you can apply PLS-SAM. And PLS-SAM is also adjusting the normality problem by giving you bootstrapping algorithm. So bootstrapping algorithm converts the non-normal data into a normal data, and whatever result you will get are basically on the normal distribution. So that's why whenever you say PLS, why you are using PLS? Because it is a non-parametric. So the logic of defending this question is that we have used bootstrapping algorithm with 5,000 subsamples, and after this we assume that we are getting the parametric results. So this is the problem defending by PLS. A sample size in CBSM at least 200 sample is required. But in PLSM, even you can run on a small sample, 50 sample, 100 sample, you can apply PLSM on very small sample. So in case if you have a small sample, this is one of the reason for moving the PLS. Then the analytical focus. CVSM is used for confirming theoretically assumed relationship. If any relationship is coming from the theory, like theory of planned behavior, theory of reasoned action, UTET model, then the scholars are preferring CVSM. And PLSM is for prediction. If you analyzing the relationship between the constructs, and the prediction is the important objective. So if you want to run a model which requires prediction, then PLS is preferred. So anything which is not supported by the theory, any relationship which is not supported by the theory, the PLS is very good in that. So you can say my model is having good predictive power. So in PLS, we talk about the predictive power or external validity. However, CVSM is not talking about the prediction or prediction power. The CVSM is talking about the hypothesis testing, whether your theory is confirmed or not. So this is one of the basic reason of using CVSM and PLS. Now, number of indicators. In AMOS, it is mentioned, it is mandatory that you must have at least 3 items, 3 statements in a construct. But in PLS, even if you have 1 item, it is sufficient. So this is one of the important difference between CVSM and PLS. And in CVSM, you can use only reflective. In case if you have formative construct, then CVSM will not work. You have to go to PLS. And only in CVSM, you can use only interval scale variable or a ratio variable. In PLS, you can use categorical also. So this is one of the difference where the PLS is much better. And complexity of the models. Like when you have very large model, where more than 100 items are there. So whenever the number of items are more in the model, the CVSM will give you a problem. Even in second order construct, the CVSM is giving you a problem. But PLS is very, very effective in handling the large models, model with second order constructs. PLSM is very, very effective. So these are the reasons mentioned in the book written by Ringel. And so I just summarizing it. So why we are using CVSM? Large sample size, normally distributed data, only reflective measures, theory testing approach, hypothesis testing, only scale variables, relationship between the construct you want to see, and PLSM, non-normal data sample size, small sample size, formative measures, research objective prediction. Objective of the research is prediction, complicated models, categorical variables. So these are the differences or the objectives of using PLS and CVSM. But in recent time, I have seen, even if you have large data, even if you have theory-based objectives, the research scholars are using PLSM. So they are preferring the PLSM. So the literature is defining or differentiating the CVSM and PLSM by this. But the scholars are shifting slowly and slowly from CVSM to PLSM because of many reasons, that it is easier to use and we are having different advanced algorithm in PLSM which is not available in AMOS. Like in SmartPLS 4, we are having very advanced algorithms like PHYMIX, prediction orientation, POS segmentation, the permutations, the blindfolding, the PLS predict. Then we are having Gaussian copula. So there are different advantages or there are different algorithms which is available in PLSM. These are not available in MOS. So that's why the scholars are shifting from SAM to CVSAM to PLSM. And now, uh, now I'm going to do this exercise. So data I will share in the folder. And while doing this exercise, I am showing you many new commands which is available in PLS4. In this case, in this model, it is a first order SAM model. Behavioral intention is a dependent variable. And 1, 2, 3, 4, 5. These four are independent variables. So how to make this model and using SmartPLS. So I'm showing this exercise to you. And after I will also tell you that how to save this SmartPLS project so that you can share this project with anybody else. So these two exercises we are going to do. So let's see one by one. I am opening the SmartPLS. There are many new things which is available in SmartPLS 4 now. SmartPLS 4 is very effective. So this is the front page. And we are having three type of models: PLSM, regression, process. So I'm creating a new project. So before running this, I hope you understand what is how to choose the workspace. First of all, software is requiring a workspace. You can see that this is a folder. And the benefit of creating this folder is that any project you are creating by default saving in this space. Okay, so now I am opening a new project. The new project is day 2 and create. Now you have to import the data file. There are two types of data file you can import. One is the Excel file CSV format, and second is the SPSS file. So now I am importing the exercise 2 behavioral intention. I put in the Excel format, and if I click it, the software is importing the data. So first of all, software is asking you that what is the nature of the variable. So number one, serial number, I know that it is categorical, or even you can remove it. If you don't require it, you remove it. So click, include it, remove it. All the variables are metric, so I'm keeping it. Number of missing values, you can see here. So no missing values there. And scale is 1 to 5 scale. You can see that 1 to 5 scale. So data is available in 1 to 5 scale. And after that, you just click on import. And when you import, the data file will come here. Yeah. So the software give you basic analysis before going to the model. Number one, type of the variable, missing value, average, median, scale minimum, scale maximum, and the most important is deviation, kurtosis, skewness. So these three input, these three results you have to report in the thesis also. All the axis, kurtosis and skewness are expected to be less than 1 for a normal distribution. So in this case, we are having some of the variable, but these are genders. Not we cannot check. Should not check that. Yeah, BI1 is more than 1, a problem. So FC3, FC4 are skewness, kurtosis is more than 1, problem. So all the values are expected to be less than 1. If you want to check the correlations, you can check the correlations like this and go back. So you have to go back. If you want to save the result, you can go to the export to Excel. Otherwise, go back. Now, once you import the data, so this is the data. And now we are going to create a model. So when you create a model, the software will ask you which type of model you want to create. So there are model type. There are three type of models. One is PLSM, regression process. So today, first we have to go for PLSM, and someday I will show you the regression and process also. So PLSM. Now name of the model, I am making the SAM model, SAM, save. So the model is here, and all the variables you can see here. So I am creating a model. So PU means perceived usefulness. So I just drag and drop and changing the name. So you should type the full form of the variable. So perceived usefulness is coming here. If you want to create a space, so you can use this zoom option. So I am creating this space. Now we have to manage this also. First of all, if I click on this, I want useful below the perceived. So you have to do this. And if it is you want to change the reflective formative, you can change from here. If you make it formative, so you can see the arrow is coming like this, and just click on this again. If you want to make it reflective, change reflective, because in PLS3 the system was different. In here the PLS is the method of converting reflective and formative is this way. Apply. So now this is perceived usefulness. And if you want to increase the font size, you have to go here. So if you select this and click on this text, so you can see that we can increase the font size, we can decrease the font size, and all the items I want to shift to the left hand side. So I will right click, align indicators to the left, so they will go to the left, and then you have to arrange as per your choice. So today after the session, you have to make this exercise, you have to do this exercise like this. And even if you yeah, now this is a clear. So I don't need border, so this is coming by default, and if I control Z, it will come like this. Similarly, we can do for others. So this is perceived ease of use. And again, I have to shift to the left, and so you have to manage like this. Similarly, click on this. Perceived ease of use, you have to write, you have to manage the words, how it look like. It is reflective, and apply. Want to increase this, increase the text size like this. Similarly, I am repeating for others. This is self efficacy, shifting to the top. So one or two items comes on the top, and So playing with the software is important for a practice. And facilitating conditions. Okay. Now we are having hedonic motivation. So this new software is quite amazing software, and I'm taking it left hand side again or bottom. So in bottom, the problem is that sometimes this line will will be over the heading, so we can manage like this. And finally, the dependent variable is behavioral intention. This is my dependent variable, and all reflective in nature. Okay. After that, I want to connect each other. So I go to the connect, and you can connect like this. So when you connect, it becomes blue. And to manage the space, you just zoom and like this, and you can go to select if you want to change the shape or you want to move. So this is my model ready. Okay. So uh, when this is ready, you just go to the calculate, and in calculate, if you click on consistent PLS algorithm, this is for validity testing. Like if I go to this, click on this, start calculation, and you will get the result. So all the result you can see here, like construct reliability and validity, we can check Cronberg alpha, this. So all the results we will discuss slowly and slowly. And if you want to go back, so go back. So this diagram you can use for thesis or in a paper, but this is only for testing the validity. Again, if you go to calculate, you just see this calculate. So we will do all these things in the coming sessions. So tomorrow I will focus on consistent failures algorithm, only this part. On some day I will focus on this part, then this, then this, then this. So slowly and slowly we will do all. So if you go to the bootstrap, the software is asking you that how many bootstrap sample you need, so you can increase it, but by default is 5,000. And amount of result, if you want less result, you can go for faster, otherwise go for slower. So I suggest you to go slower because R square will come, otherwise in faster R square will not come. And type of bootstrap is percentile bootstrap, two-tailed, fixed speed. Just go to start calculation, and the software is running, and all parameters you will get. With 5,000 subsamples, the process is little slower. Yeah. So now we are having the result. So you can see all the results are coming here. Path coefficients and t-value, confidence interval. So r square, f square. So all the values are coming. And to go back, you can go back. So again, the model will come. So in this way, we can run the model. Then we have to go back. And before going back, save the changes. So day 2 is actually called project. So like if I want to export this project, so you can just go to the export the project. And this project you want to save. So wherever you want to save, you can save it. So you can save like a SmartPLS workshop. The day 2 is already there. But you can also save in terms of zip file so that you can send this file to somebody else. So you can save it. So similarly, you can save the project very easily. Otherwise, when it is done, you can send to the archive. So if you click on the archive project, so it will go back in archive. And when you want back, you just take it back, restore project from archive, it will come back. Because sometimes number of projects are too many. So we can, if we are not working with the project, we can send the project into archive. Okay. So similarly, if you want to do the regression model, you just click on this and new regression model. So save. Now you can analyze the regression model because we are not having the scores. So we are not working on regression model today, but tomorrow I will show you that. So today the objective is to just make the models like this. So you have to do practice on behavioral intention, make the model, and slowly and slowly we will move. So that's it for today. Keeping for day 1 and day 2 light because many people are learning first time. So I'm keeping light sessions on day 1 and day 2. From day 3, we will move to the technical side. So ending my session now. So asking for the problems. So these session 2 and light, and from day 3, we will move to the technical side. Before that, I want everybody to do a small practice, whatever we did in today.